Hey, welcome to this video on Newton's first law of motion. Did you know that there's a species of antelope capable of jumping higher than the average house? That's because it has powerful hind legs and the fact that the average house cannot jump. I know. Okay, we're talking about Newton's first law of motion, so that means that by the end of this lesson, my hope is that you can connect the concept of balance or unbalanced forces to changes in motion using Newton's first law and describe the concept of inertia, and its dependence on an object's mass. So to get a sense of this, let's first watch this clip of a video where some crash test dummies are going to show us the experience of getting into a pretty serious car crash, a head-on collision, and this video happens to be an illustration of the importance of wearing a seatbelt even when you're sitting in the back seat. So take a look, and let's notice what happens. So the car is flying backwards to simulate what happens after the impact, and notice what happens to the passengers. They seem to be flying forwards. And why is that? Well, what you might observe is that in this case, it appears to us that these dummies are sitting still and the car is moving backwards. But what actually happens in a car crash is that the car suddenly stops moving and the people don't. So as a result, the people go flying forwards, just like that, right? The people go flying forwards, and if you're not belted in, you'll go flying into the front passenger seat or the front driver's seat and then go flying backwards, which is awfully painful. And so the point is that if you wear your seatbelt, while you might snap forward, you won't slam into all of those other things. But the reason this is happening is because you, the passengers, you are in motion. The car suddenly changes its motion, but you aren't. You aren't actually part of the car. You're moving with the car, but then the car's motion changes in an accident and yours doesn't, which results in this dramatic sort of thing happening, and a reminder of why we wear our seatbelts even in the back seat. So what's Newton's first law? Well, Newton's first law tells us that an object in motion will remain in motion unless acted upon by an unbalanced force, right? So you probably already know this. Objects in motion remain in motion, but it's acted upon by an unbalanced force that changes it. So forces can be in balance, and things will remain in motion, or things that aren't moving will stay not moving unless they're acted upon by some unbalanced force. So that ball is going to sit there until you kick it, which is going to apply an unbalanced force and change its motion from sitting still to moving. Quick reminder, motion itself does not require force. And the reason this part can be hard for us to understand is because in the real world on planet Earth, there's almost always some force kind of getting in the way of our motion. And that's usually something like friction or gravity or air resistance. So for example, if you throw a ball, sooner or later it's going to slow down, and there's two big reasons for that. One is the air resistance is pushing against it, slowing it down, and the other is gravity is pulling it downwards. But if you go out into outer space where you no longer really have to contend with gravity or air resistance because there's no air, one little start of a motion and you will just keep going. So for example, this is an astronaut in this sort of jet mobility pack that was designed, I don't know, a couple decades ago, I think. And what they're able to do with this is just one tiny little sort of puff of gas will push the astronaut in one direction, and then without any more puffing of gas or any more doing of anything, the astronaut will remain in that motion. And essentially, once you're out in outer space, kind of forever. Unless you get pulled in by the gravity of a planet or something like that. You're just going to keep going the way you were going because there's no force to unbalance what's going on. All right, so Newton's first law of motion is also called the law of inertia. And inertia is a term we should know well. Inertia is the resistance of an object to changes in its position or motion. So just like things that are sitting there will tend to not go anywhere unless you really change its motion, right? And so there's a lot of inertia in, say, A wall, you can push on it and push on it, but you yourself probably cannot change the position of that wall. There's a lot of inertia there. Or something is moving, right? Something is moving, and it takes a lot to change that motion, to stop it or redirect it. And an object's inertia depends only on one thing, simply on one thing, and that is its mass. More mass, more inertia. Less mass, less inertia. Good illustration might be, we've got these two buckets here. This one's empty, this one's filled with sand. You can push this one back and forth really easily. This one's harder because there's a lot more mass in there. And a really good and very relevant to our purposes illustration, or very relevant to our lives illustration, is the use of runaway truck ramps. So you've probably seen runaway truck ramps on the highway to stop awful things like what you see in this video. So if you watch this video, shot by somebody driving down I-70 towards the mountains, you see the truck go flying up that runaway truck ramp. So thankfully, this is a truck that had lost all of the control of its brakes. Thankfully, that ramp was there, and it was able to go up the ramp and stop instead of crashing into the side and causing a major accident on the highway. So something to be aware of. But of course, why is it a runaway truck ramp and why isn't it a runaway car ramp? Perhaps a car could do it, but a car doesn't need quite as much to stop because a car doesn't have nearly as much inertia. You know, a truck, we're talking about maybe 10 times the mass at least. So it's much greater inertia. It requires much more braking force to change its motion compared to a car. And that's why trucks' brakes are more likely to fail. And you need something dramatic like this huge uphill gravel ramp that will stop its motion because it has so much inertia. So that's it for Newton's first law of motion, and the law of inertia, as it's also called. And keep that stuff in mind. An object in motion remains in motion, or an object that's not in motion remains not in motion, so long as there are no unbalanced forces applied. See you in the next one.